Welcome to World Decoder. Today we explore hypersonic weapons, a revolutionary technology changing the very fabric of modern global warfare forever.
The projected trajectory on the eastern seaboard is accelerating. We need to reroute the satellite imaging now. If this missile reaches Mach 10, intercept is impossible.
For decades, military engineers have constantly pushed the boundaries of aerodynamics, desperately trying to build faster and more elusive combat projectiles. Breaking the sound barrier was once considered impossible, but human ingenuity quickly surpassed that limitation during the early days of aviation. Today, moving at merely the speed of sound is no longer sufficient for modern militaries seeking absolute dominance over their adversaries. Enter the hypersonic era. This is a terrifying new domain where projectiles travel at mind-boggling velocities, exceeding Mach 5 easily. Traveling at Mach 5 means moving at least 5 times faster than the speed of sound through our dense planetary atmosphere. At these extreme velocities, the standard laws of conventional aerodynamics begin to break down, revealing entirely new and complex physical phenomena. Engineers and scientists widely consider achieving sustained hypersonic flight to be the ultimate holy grail of modern advanced missile defense technology. Episode 9 of World Decoder will completely deconstruct the complex mechanisms that make these incredible hypersonic weapons virtually impossible to intercept. We will closely examine how specific weapons severely challenge every single existing missile defense network currently deployed around the modern world. Let us begin by analyzing the Kinzhal, an air-launched ballistic missile modified specifically to reach staggering hypersonic speeds during flight. Carried by supersonic interceptor jets, the Kinzhal is dropped from high altitudes, giving it a massive initial kinetic energy boost immediately. Once its powerful rocket motor ignites, the weapon accelerates rapidly, tearing through the thin upper atmosphere at absolutely terrifying operational speeds.
If we move the compressor stage here, we improve the thrust ratio.
Object moving
that
so
aligns
fast
with the data
can
I just
destroy
ran.
heavily
Good.
fortified
Revise the
underground
master
bunkers
print.
almost instantly. Next, we must consider the Zircon, a fearsome naval cruise missile designed specifically to dominate maritime warfare in the modern era. Unlike the Kinzhal, the Zircon uses an advanced scramjet engine to maintain its incredible hypersonic velocity while cruising at lower altitudes. A scramjet engine continuously compresses incoming high-speed air, mixing it with fuel to create a sustained and powerful forward thrust. This continuous propulsion allows the Zircon to fly vast distances while remaining incredibly close to the surface of the open ocean. By flying low and exceptionally fast, it effectively evades early warning radar systems, giving enemy warships absolutely no time to react. Finally, we arrive at the Avangard, perhaps the most terrifying and technologically complex hypersonic glide vehicle ever developed by human engineers. Launched into space atop a massive intercontinental ballistic missile, the Avangard detaches and begins its violent descent back into the atmosphere. Instead of falling predictably like a stone, it uses its unique aerodynamic shape to surf gracefully upon the dense atmospheric layers. This skipping motion allows the Avangard to travel thousands of miles at speeds reportedly exceeding Mach 20, an absolutely staggering figure. But flying at speeds above Mach 5 presents massive engineering obstacles. The biggest challenge is definitely not the engine, but heat. At these incredible velocities, atmospheric friction generates an intensely hot plasma layer that completely surrounds the entire body of the missile. As the weapon violently pushes through the air, it compresses the gas molecules ahead of it, generating unimaginable thermal energy. Temperatures on the leading edges of the vehicle can easily exceed 2,000 degrees Celsius, hot enough to melt solid steel. This superheated plasma creates a massive radio blackout, making it exceptionally difficult for traditional radar systems to track the weapon. The plasma absorbs and scatters incoming electromagnetic waves, effectively cloaking the hypersonic missile from desperate defenders trying to locate its position. This unintended stealth characteristic makes hypersonic weapons incredibly dangerous, as they remain practically invisible until they are dangerously close to impact. Furthermore, the immense thermal energy generated by this extreme atmospheric friction would instantly melt and destroy standard aerospace manufacturing materials completely. Traditional aluminum and steel alloys would vaporize in mere seconds under such brutal thermal stress and intense aerodynamic pressure during flight. To survive this brutal environment, modern hypersonic weapons utilize highly specialized titanium alloys and advanced heat-resistant ceramic surface coating materials. Titanium provides the necessary structural integrity, ensuring the weapon does not tear itself apart while maneuvering violently at blistering high speeds. Meanwhile, the advanced ceramic coatings act as an impenetrable thermal shield, protecting the delicate internal electronics from catastrophic failure during flight. Developing these exotic materials requires billions of dollars in research and access to the most sophisticated material science laboratories on Earth. Even a microscopic flaw in the heat shield could lead to the total vaporization of the weapon long before it strikes. The manufacturing tolerances are incredibly strict, demanding absolute perfection from the engineers and technicians assembling these devastatingly fast modern delivery systems. Now let us look at the fundamental differences between traditional ballistic missiles and the new generation of highly maneuverable hypersonic vehicles. Traditional ballistic missiles strictly follow a predictable parabolic trajectory, making their exact landing coordinates relatively easy for defensive computers to calculate. They launch high into space and fall back to Earth, governed entirely by the unforgiving and highly predictable laws of gravity. Because their path is governed by basic physics, interceptor systems can accurately predict exactly where the ballistic missile will be next. Modern air defense networks are specifically designed to calculate this parabolic curve and launch interceptors to meet the threat mid-flight. Conversely, a hypersonic glide vehicle like the Avantgarde operates entirely differently, maintaining extreme maneuverability while traveling deep within the Earth's atmosphere. It does not follow any fixed geometric path. Instead, it continuously alters its flight direction with incredibly high acceleration and agility. By staying within the atmosphere, the glide vehicle uses aerodynamic lift to steer left, right, up, and down with terrifying precision. This radical unpredictability means that enemy air defense systems absolutely cannot calculate a viable intercept point for their countermeasure missile strikes. Every time the defensive computer calculates a potential interception coordinate, the hypersonic weapon has already violently changed its erratic flight path.
Look at the alignment here. The tensile strength seems significantly improved at the nanoscale.
But the mouse is moving
data
at
correlates
5
perfectly. Let's record
kilometers
this
per
sequence.
second. Controlling a physical object flying at several kilometers per second while maintaining perfect aerodynamic stability is a monumental mathematical computing achievement. The extreme aerodynamic forces acting upon the control surfaces are immense, requiring perfectly calibrated digital actuators to make constant microscopic adjustments. It represents the absolute pinnacle of digital control algorithms, processing millions of variables per second to keep the weapon perfectly stable. The onboard flight computers must instantly react to changing atmospheric densities, unpredictable wind shears, and massive thermal fluctuations during the journey. A delay of even 1 millisecond in processing these variables would cause the weapon to tumble out of control and disintegrate. This requires incredibly robust and radiation-hardened microprocessors capable of executing complex navigational mathematics under the most extreme conditions imaginable today. Without these advanced digital brains, these weapons would simply be uncontrollable movements, burning up harmlessly in the upper layers of our atmosphere. The marriage of cutting-edge material science and unprecedented computational power is what truly makes hypersonic flight a devastating military reality. Hypersonic weaponry is fundamentally not just about raw speed. It represents a complete paradigm shift that fundamentally alters the rules entirely. For decades, military strategy relied heavily on the concept of deterrence through guaranteed mutual destruction and highly advanced early warning networks. Nations felt secure knowing they had ample time to detect an incoming launch and deploy their sophisticated defensive countermeasures without panic. But when an incoming threat moves this fast, the reaction time for defensive forces is brutally reduced to just a few seconds. Human operators simply cannot process information quickly enough to authorize and execute a successful interception against such a blindingly fast target. Consequently, many currently deployed air and missile defense systems instantly become tactically obsolete due to their inherently slow mechanical response times. Even fully automated defensive grids struggle to track, target, and fire upon a vehicle that violently maneuvers through a blinding plasma sheet. This terrifying evolution signifies a major transition from passive defensive strategies to a highly active environment where advanced materials dictate absolute supremacy. The mastery of complex control mathematics and extreme thermal engineering are now the primary factors deciding victory or defeat in combat. Militaries around the globe are now scrambling to develop their own hypersonic capabilities to avoid falling behind in this crucial technological race. It is a new arms race, not measured in the explosive yield of warheads, but in raw speed and unmatched maneuverability. Whoever controls the hypersonic domain will possess the absolute power to strike any target on Earth with complete and total impunity. The psychological impact of such a weapon cannot be understated. It instills deep fear and uncertainty in the minds of opposing commanders. Knowing that a devastating strike could arrive without any warning fundamentally changes how nations approach diplomacy and international conflict resolution strategies. Traditional aircraft carriers, once the ultimate symbol of global power projection, are now extremely vulnerable targets for these unstoppable hypersonic sea skimmers.
The inbound contacts are maintaining their slow trajectory,
could theoretically disable or destroy a
Lieutenant.
multi-billion-dollar
Keep me informed
warship
of any
before its
changes.
crew even realizes the danger. This
We are losing the
vulnerability
primary
forces naval
system. I
commanders to
repeat, we are
rethink their
losing it.
entire
The
operational
bypass isn't
doctrines,
working. I need
pushing
more
their
time.
precious carrier
cables
strike
are
groups
secure.
further
It's an
away
internal
from hostile
failure.
shores. Defending against these weapons requires a completely new approach, perhaps relying on directed energy weapons or advanced space-based kinetic interception networks. Lasers travel at the speed of light, making them theoretically capable of engaging a hypersonic glide vehicle during its terminal flight phase.
Tracking
However,
impairment.
developing laser
Warning.
systems powerful
Signal
enough to burn
degradation.
through advanced
Targeting
ceramic
failure.
heat shields
Target
remains a
lost.
massive and
Evasive
unsolved
maneuver
engineering
successful.
challenge right now. Furthermore, the blinding plasma shield that surrounds the missile might actually deflect or absorb the incoming laser energy, rendering it completely useless. As offensive weapons continue to evolve at this terrifying pace, the delicate balance of global military power becomes increasingly fragile and unstable. The development of the Kinzhal, Zircon, and Avangard systems proves that we have officially crossed a dangerous threshold in modern warfare technology. We are witnessing the dawn of an era where pure kinetic energy and uncatchable speed replace the explosive power of nuclear warheads. A solid metal rod dropped from space at hypersonic velocities would strike with the devastating force of a small tactical nuclear weapon. This
could they
terrifying
know?
concept, often
We've
referred
lost
to as
the element
kinetic
of surprise.
bombardment, is rapidly becoming
Scramble
a
the
plausible
reserves
reality
now.
thanks to these recent advancements in aerospace.
A
The
pleasure
physics of
doing
hypersonic
business with
flight
you.
are beautiful in their
Indeed.
mathematical complexity,
To peace
yet absolutely
and
horrifying
prosperity.
in their destructive and deadly military application potential. Understanding these complex systems is absolutely crucial for anyone trying to comprehend the shifting geopolitical landscape and the future of global security. The race to perfect hypersonic technology is not just about building better missiles, it is about securing absolute dominance in the skies. As engineers continue to push the absolute limits of material science and thermodynamics, we can expect even faster and more maneuverable weapons. Perhaps one day defensive technologies will finally catch up, creating a new equilibrium in this endless cycle of military innovation and escalation. But for now, the hypersonic missile reigns supreme as the ultimate apex predator of the modern, highly contested global aerospace combat environment. The sheer speed and agility of these incredible machines remind us of humanity's boundless capacity for both brilliant innovation and terrifying destruction. We have truly entered an unpredictable new chapter in military history, where the fundamental laws of physics are weaponized to unprecedented extremes. The technologies we discuss today represent merely the beginning of this rapid evolution in ultra-fast, highly maneuverable advanced aerodynamic flight systems. Future developments will likely
The launch
introduce even
confirms
more
it.
sophisticated
We have
artificial
officially
intelligence
crossed a
integration,
dangerous
allowing these
technological
weapons to
threshold in
autonomously
warfare.
select targets during their hypersonic glide. As we continue to decode the complexities of our rapidly changing world, understanding these technological leaps becomes vital for our collective future. Thank you for joining us on this deep dive into the fascinating and terrifying mechanics behind modern hypersonic missile delivery weapon systems. We hope this analysis provided valuable insights. Stay curious, keep questioning the world around you, and subscribe to World Decoder for more.